So, good evening, everyone. I'm Himanshi, and we are here to complete our chapter that is probability. Okay, so before going to the chapter, I want to tell you something about Swiflearn. Swiflearn actually a platform that provides you a balance or balance in your studies when you are at home. As we know, we are into a very bad situation that is COVID. So, for that, let's not stop our studies. So, you can go for Swiflearn for that. Okay, so, what Swiflearn provides as the key features, you can see that it provides a test series, beautiful sets designs, and you can also go for the live test here also. So, just visit the app so that you will be able to see everything. So, before going to the topic and before jumping into the topic, let's first subscribe, press the bell icon, and stay tuned to our channel. Okay, so yes, where we left at probability. Okay, at the last time we will discuss about that how the events, how the trials, how the outcomes are there in the probability. Okay, and how we will calculate it. We will also go through some very live examples and we discuss about it and we just go through the definition and the basic properties of probability. So now we are here with some other objectives. First, we will learn about here the theoretical or classical probability. That is very important type of probability that we have studied and we are going to study it in 11th and 12th class also. So please pay kind attention towards them. After that, we will define and explain the complementary event and we will see that how complementary events are there in the probability. Then we will see the impossible events, that how impossible events even have the some sort of probability. Then we see the sure and the certain events. Then we find the probability of different events which occur in our questions. Okay, so first let's go for some live examples that we always go. And here we have an example of a ISRO satellite. So yes, when we study about something, the satellites launches by the ISRO, that is Indian Space Research Organization, when it launches some satellite, it always go for the probability function. Okay, that the satellites will go at the point or not, or it will go for, it will achieve the destination or not, or what will happen to the satellite, it will burst off or not, what will happen. So when scientists over there make machines that use high-tech technologies cannot take thousand values of any experiment, as it is very expensive, unlike tossing coins for thousand times. Okay, so yes, obviously, like for example, I have a coin, I can toss it like thousand, millions of times. I have a lot of time, I can do that. But when it comes to a satellite, seriously, we can't take a risk off with a satellite. So with a satellite, we have to see whether we will able to perform the experiment again and again. So for that, we have to see whether the probability in the first case lies probable that the outcome will occur or not. Okay, so here we are with the theoretical probability that explains the idea that why we are not able to see it in the launch of satellite. Okay, for example, when we talk about the probability of something happening, okay, we just do what? We just transform it to the formula that is P of E, okay, equals to the happening of the event. Okay, whatever the event will be, we want to happen it. Okay, for example, we have to draw a card from the shuffle of 52 cards. Okay, or we have to, like roll a dice and we want to get a 6, whatever it is. Don't matter. After that, we will put the happen of a event whole upon the possible number of outcomes having from not that event, from all the events. Okay, it will make it more rigorous and the probability reduces to zero almost. And we are not able to get that what exactly we want as an answer. So here we are here with the theoretical probability. The requirement of repeating an experiment that has some limitations as discussed earlier in the satellite form function, as it may be very expensive and unfeasible. When we see something very expensive, जब हमें लगता है कि कोई चीज बहुत महंगी हो सकती है, and we are not able to afford that again and again. तो हम चाहते हैं कि वो चीज एक बार में बहुत अच्छी सी हो जाए. For example, we go to buy a car. Okay, we all analyze the cars and we always want the best car for us. Okay, we never want to miss the chance to have the worst car. Okay, we always want to eliminate the chances of getting the worst car. Okay, so what are these? We are eliminating the chances of getting failed, and by getting the by getting the answer positive accordingly. So for that we have to revise the theoretical probability so that we were able to see that whether the situations are in our favor or not. Obviously, it worked well in a coin tossing and the experiments that we can do at home that are very inexpensive and very easy. But when it comes to a very big decision, we have to see it very carefully. Okay, so it can be buying a house, it can be buying a car, it can be buying anything. Okay, so how about repeating the satellite launch? It will be more expensive, especially for the country. We have seen from the countryside, from us side, even this launching of a satellite is very difficult. We don't launch the satellite daily, obviously. So, yes, when we talk about the probability of being failure and we know about the outcomes of our failure and the probability of failure, we are more curious and more thinkable about the issue. For example, I know when I launch something, for example, if I buy this car, I have two cars, suppose car one, car two. And if I know buying car two is going to be a big failure after 3-4 years back, then what I will do? I will go for car one, obviously. So the probability here tells us that in which decision we have to invest or not, and if we have to do some reconstruction into it, then what it will be. Okay, so here we are in experiments where we are prepared to make certain assumptions, the repetition of an experiment can be avoided. Obviously, we just want that we are just good with the experiment in one go. We don't repeat it again and again. It will make regress for us also. So assumptions help in directly calculating the exact theoretical probability. Sometimes assumption helps. For example, if I'm a scientist and I built a satellite, okay, probably with everything, with watching everything clearly, and I know that there is a lack of something, then that assumption will work as a reconstruction or reformation of that satellite again. Okay, the formulas, everything is tested again and again to get to the point that whether the satellite is ready for the testing or not. Okay, so assumptions sometimes help us to go for the theoretical probability also. Assumptions of equally likely outcomes, which is valid in many experiments. Okay, and some experiments will go on their way. We don't know how will they do. Okay, so the theoretical probability, also called the classical probability of an event E, written as P of E, that we have written that P of E. Okay, P of E, and it can be defined as not the same one that we have studied earlier. It will be the number of outcomes of favorable to E pull upon the number of all possible outcomes of that experiment. Okay, whatever the outcomes we are getting from that experiments upon the number of favorable outcomes to E. Okay, to that event, what are the favors? Okay, and what are the possible outcomes of getting the outcomes from the experiment that we are doing. So this is the basic formula that we have to always keep in mind while doing a question. Okay, and this will act as a base for many questions. For example, a bag contains a red ball. Okay, we have a bag full of so many balls. We have a red ball, we have a blue ball, we have a yellow ball, and we have all the balls being of the same size. Okay, so Mishka, a girl, takes out a ball from a bag without looking into it. Okay, for example, I have a bag full of balls and I have to just take out one ball without looking it. Okay, she takes out the ball. So the ball being yellow, the ball being red, the ball being blue. Obviously, these three balls will carry out, and we have to do what? We have to find the probability of having the ball yellow, having the ball red, and having the ball blue. Okay, so let's see how we will move it. So we do what? Mishka take out the balls, and she take out the balls equally. She take out one by one. Okay, so let y be the event. The ball taken out is yellow. Okay, we let y be the event for the yellow ball, and b be the event for blue ball, and r be the event for the red ball. Okay, so we will see now what we will up to. Okay, when we just put the experiment and we will put the balls up to the mark, we will see that Mishka has taken, we have the three possible outcomes. Obviously, either it will be red, either it will be blue, either it will be what? Yellow. Yes, so we have only three outcomes, so the number of possible outcomes will be three, and we have to take out one yellow ball. So the number of possible outcome will be one, because the yellow ball is one only. Okay, so the number of favorable outcome will be one here. So we have P of y as 1 by 3. After that, we will see the number of outcome favorable to B equals to 1. That is blue ball equals to 1. Okay, so here P of B is 1 by 3. Is that clear? What are the possible number of outcomes we have taken? 3. Why 3? Because we have 3 balls. That is blue ball, red ball, and yellow ball. Okay, so we have the number of possible outcome as 3. Okay, and the number of favorable outcomes to the event is 1. So 1 by 3 is for P of y, 1 by 3 is P of P, and same goes for P of R, that will be 1 by 3. Okay, I guess this question will clear to you, and the formula that we have, P of E, is exactly equals to what? The favorable number of outcomes to event E whole upon the number of possible outcomes from that experiment. Okay, is that clear? So yes, what we will observe from this question, an event having only one outcome of the experiment is called an elementary event. Okay, when we see that happening of an outcome is only one, it will be called as elementary event. Okay, all the three events Y, B, R, that is having drawn yellow ball, blue ball, and red balls, are the elementary event. Okay, the sum of the probabilities of all the elementary events of an experiment is 1. Obviously, I already told you, when you plus all the possibilities of happening of an event from one experiment, it will always equals to 1. And the probability lies from which center? 0 to 1. Okay, always you have seen that your probability will lies between 0 to 1. So we have observed that P of I plus P of R plus P of P is equals to 1. So this is true in journal also. Obviously we have what? We have here 1 by 3. Okay. And here we have also plus 1 by 3. Okay. And again we have what? 1 by 3. Okay. Then we have to take the LCM. LCM will be 3. Okay. And it will be 1 plus 1 plus 1. So it will be 3. And when we divide 3 by 3, we will get 1 here. So I guess it will be clear to you. Okay, what are the elementary events? The events that have an outcome 1 is called the elementary event. Okay, for an example, we have already done a question. Okay, so here all three events that having the probability in total 1, and as an individual 1 by 3, 1 by 3, 1 by 3 will be elementary event. Okay, now we have another question. Two players, Geeta and Anika, placed a tennis match. Okay, maybe they love tennis. Okay, it is known that the probability of Geeta winning the match is 0.68. Okay, I have two persons here. Okay, that is yeah. I have two persons here, Geeta and Anika. Okay, they says the probability of winning Geeta will be what? 0.68. Okay, then we have to find what? The probability of Anika winning the match. Okay, so from getting the probability that Geeta is winning a match, we will have the probability of Anika losing the match. How? Think about it. I will tell you in the last of the question. Okay. So yes, how we will do that? We will do that with the question by reading it properly. Okay. For example, we have Geeta here, we have Anika here. Okay. They says that winning Geeta is 0.68. Okay. It means we have winning probability of Geeta as this, then the left out probability is will be winning the match by Anika. Okay, so when we deduct it from mind 1, it will be 0.32. Okay, now you will say, ma'am, how you will predict that? Okay, that's very easy. When we see the probability of happening two events will be 1, okay, then the two persons playing the match, winning both of them, the probability of winning both of them simultaneously, not exactly same time, but from other different time, it will be equals to 1. Okay, so when we deduct the probability of winning the one person, it will be 1 minus the probability of winning the other person. Okay, is that clear to you? Yes, it will be clear to you. Okay, and we have the probability as equals to 1 for the all the events. Okay, yeah. Now we have this question. Suppose we throw a dice once. What is the probability of getting a number greater than 2? Okay, if we throw a dice once, okay, and we are finding out the probability of getting a number greater than 1, greater than 4, sorry, then we have to do what? First, we have to get it to the sample space. We have studied in the last class. I have already told you what is sample space. Sample space is the place where we will write down all the possible outcomes happening of an event. Okay, first we will do what? First we will let E be the event of getting a number greater than 4. Okay, after that, the number of possible outcomes is 6. How 6? We have to do what is the probability of getting a number greater than 4. Okay, so the greater than 4 will be 5 or 6. Okay, and we have these numbers as 6. If we have talk about the possible number of outcomes. Okay, if I'm rolling a dice, I will get 1, I will get 2, I will get 3, I will get 4, I will get 5, I will get 6. Okay, these are the number of possible outcomes. But what I want to get? I want to get a number that is greater than 4. It means I want to get a number that is greater than 4. That is, it will be 5, either it will be 6. Okay, so for getting the number 5 and 6, it means I have to do what the favorable number of outcomes will become, the 5 or 6. Either I get 5, I will win. If I get 6, I will also win. Okay, so when we talk about this probability, it will equals to 2. The favorable number of outcomes will be 2. So the probability will be 2 upon 6, that is 1 by 3. Okay, and now we have the next question as the event getting a number less than or equals to 4. Okay, now we want a number that is less than 4. Okay, now you tell me what are the numbers that are less than 4? Is 1, 2, 3. Okay, we have 3 numbers, but the number of possible outcome will remain same. It will be 6. Okay, so the outcomes favorable to the event F are 1, 2, 3, 4. So the number of outcomes favorable to F is 4. Okay. So it will be 4 by 6, that is 2 by 3. Okay. So do you think the events E and F are the examples of elementary events? Can you say that? Ki ma'am, these are the examples of elementary event. We already talked about the elementary events. What are the elementary events? Elementary events are basically the events that are happening because of that are happening once. Okay, so no, because E has 2 outcomes and even F has 4 outcomes. Okay, and when we have outcome as 1, then we will see that it will be an elementary event. So can you tell me about the value of P of E and P of F? What are they? Yeah, it will be 1 by 3 plus 2 by 3 and it is equal to 1 because the probability of two numbers is equals to 1. Okay, so this is the way we are saying that 1 is the number that will come when we are saying about, when we are talking about the probability of having an event, okay, within a number. So where E is the event getting a number less than 4 and F is the number getting the number greater than or equal to 4. Okay. So in equation first, F is same as not E. We denoted E by E naught or E dash. We can do anything. Okay. So it depends upon us, like E naught, we do anything. Okay. So P of E plus P of not E will equals to 1. Okay. P of happening of an event, P of not happening of an event is equals to 1. Okay, for example, we did in the last question that we have Geeta and Anisha. Okay, so the probability of getting win of Geeta is P of E and the probability of losing Geeta is P naught of E. Okay, so P of E plus P naught E equals to 1. Okay, so here we have P of E. We can write P of not E as P of E dash equals to 1. Okay, and it will give us P of not E equals to 1 minus P of E, or either way we can use that. P of E equals to P of 1 minus. Okay, so E naught representing not E is called the complement of event E. Complement, what is this? Complement is actually the number that is exactly showing opposite side of it. Okay, for example, let me give you an example. Like we use car and petrol. Car and petrol are complementary to each other. Okay, but as the demand for car rises, the demand for petrol will become more, but the price of petrol become more. Why? Because due to increase in car on the roads, the petrol become expensive, and if it's become expensive, we start demanding it less and shifting up to the diesel. Okay, so the complementary events are the events that are exactly opposite of each other. Okay, that complements each other, but they have the complement, the opposite effect on each other. Okay, so we can also say that E and E naught or E dash, whatever you want to say, are complementary events. So far we have studied about the elementary events. Elementary events are the events who has one as an outcome, and complementary event are an event who have their opposites with each other. For example, P dash and P. Okay. So let's explore more about the dice problem. Okay, dice problem is the favorite problem of the maths teachers. Okay, I must say the maths writers, everybody like this dice problem very much. You will get so many questions from dice. Okay, so study it properly. What is the probability of getting a number 8 in a single throw of a die? Okay, it's not possible. Okay, we also know that there are only 6 possible outcome in one single throw of a die, and getting a 8 is impossible. Okay, so there is no outcome favorable to 8, so the probability is 0. It will be lie between 0 to 1, and it will be 0 because 8 we are not getting 8 in a single throw. Yeah, we will get 8 in the double throw if we are getting 6 one time and 2 other time. So it will be 8, yeah, 1 5 time or 1 3 time. But in a single throw, it's not possible. Okay, so here we have P getting 8 will be 0 by 6 equals to 0. So that is the probability of an event which is impossible to occur is 0. Such an event is called impossible event. It can't happen. We are not getting 8 in any way. Okay, so this is what an impossible event. So let's explore more about the dice problems. Okay. What is the probability of getting a number less than 7 in a single throw of a die? Okay, what is the probability of it? It's 6 by 6. Okay, because if we throw once, we will always get a number less than 7. We will anyhow get the number less than 7 because we have only 6 points at the dice. Okay, so the number of favorable outcomes is the same as the number of all possible outcomes, which is 6. So therefore, P of E equals to P of getting a number less than 7 will be 6 by 6. Okay, so equals to 1, which is equals to 1. So what is this? This is the probability of getting a number is 1. Okay, so the probability of an event which is sure or certain, so we will have the probability as 1. If it is unsure, like we don't know that if we are getting it or not, we have the probability lie between 0 and 1. When we know that it is an impossible event, it won't happen, then it will be 0. But if an event which is sure to occur, it will be 1. Okay, so such an event is called a sure event or a certain event. What we will name it? A sure event or a certain event. So from the definition of the probability P of E, we see that the numerator, the number of favorable outcomes of event E, is always less than or equal to the denominator. Okay, so the number of all possible outcomes equals to 1. So P of P is always lie between 0 to 1. Okay, greater than 0 equals to 0, less than 1 equals to 1. Okay, it always in the middle of 1. So now we will see the probability of different events. Okay, now we have two friends here, Keshwa and Aniri. Oh, that's a very nice name. They are friends. What is the probability that they both will have different birthdays? Well, it's better to have friends with different birthdays because treat ka scope bhar jata hai. And when you are getting the same birthday, you will be like, yeah, what you are doing? They will do the party on the same day and you will be bored. Okay, so when they have the different birthdays, what we will have to see, Keshwa and Aniri. Okay, they are two friends and they both want the different birthdays. Okay, so first we have to look for the number of possible outcomes. Okay, so the possible outcomes will be they're having the different birthdays. It means 365. We have 365 days in a year. Okay, different birthdays means they're having different days. So it will be the possible number of outcome will be 365. After that, they say that what is the probability that they both have different birthdays? It simply means that if we are going for the different birthdays, then we have to see that 365, if the Keshwa has a birthday on 365th day, okay, then one day is gone for Keshwa and the other day will left for Aniri. Okay, so she will go for 364 days only. Okay, so if they are getting the different birthdays, it probably the person that they have, one person will have 364 upon 365 as the probability for getting the birthday on different days, because one day from 364 will go for the birthday of the other person. Okay, so the number of favorable outcome will be 365 here, and the number of favorable outcome for the different birthdays will be 364. Okay, the possible number of outcome 365. Obviously, it's a leap year. And the 364 will be the year for the possible number of outcomes. Now they say the same birthday. We have to see the same birthday of having. So when we go for the same birthday, it simply means that they are having a birthday. For example, if 29th November will be the day, so they are having the birthday on 29th only. Okay, so it will be 365 C1. Okay, as the as what? As the favorable outcome. Okay, and 365 into 365 as the possible outcome. Why 365 into 365? Because we are getting the two birthdays. Okay, so when we do the maths, we will get what? It will be, when we do the maths, we will get what? We will get 365 C1 matlab 365 as it is upon 365 into 365. Okay, and when we do the maths, if we cancel by this, so it will be 1 upon 365. Okay, we can also do it another way. Okay, for example, if we are getting the same birthday on the same day, it means it will be on day 1. Okay, whatever the day, it will be 1. Okay, and they are having a birthday on day 1. Okay, lefting all the 364 days. Okay, so this will be the favorable number of outcome whole upon the possible number of outcome, that is 365. Okay, is that clear to you? I guess is that clear to you, and it's a very good question. Okay, and always remember we have to ignore the leap year here. It means we are not getting 366 as a number. Okay, now they say a carton consists of 100 shirts, of which 88 are good. Okay, 8 have some minor defects. Okay, and 4 have some major defects. Okay, Karina, a trader, will only accept the t-shirts which are good. Okay, so we will write it out that Karina will only accept the goods that are good. Okay, we'll write it G. But Meenakshi, another trader, will only reject the shirts which have major defects. Okay, it's mean Meenakshi will have the goods with good plus MI, that is minor, and she will reject only major defect goods. So we have to find the probability if it is acceptable to Karina. Okay, first we will write down the formula, that is P of E is equals to number of favorable outcomes whole upon the number of possible outcomes. So what is the favorable outcome here? We will see. She will only take the good condition shirts. So they are 88. So number of favorable outcome will be 88. Whole upon the possible outcomes will be obviously 100 shirts. Okay, the total number of shirts. Any shirt will come if they just do the experiment. So it will be 88 upon 100. That we can write as 0.88 as the probability. Is that clear? After that, it is acceptable to Meenakshi. Okay, Meenakshi will accept the goods which will be are good and in minor and having some minor defects. Major defects are not accepted by her. So good, that is 88 plus 8, that having the minor defects. So it will be 96. Okay. So the 96 will be the favorable number of outcomes because Meenakshi is accepting the shirts in a good condition and in a minor condition. So it will be F equals to 96. That is the favorable number of outcome whole upon the possible number of outcome, that is 100. So the answer will be 0.96. Okay, I hope this question is clear to you. Okay, we have to see just that how much the shirts are accepted by the Karina and Meenakshi, and then we will just find out the favorable number of outcomes, because the possible number of outcomes is just given to us, that is 100. Okay, so we will just go for the number of outcomes that is not given to us. So it is acceptable to Karina, it is 0.88, and it is acceptable to Meenakshi, it is 0.96. It is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. Okay, we are having the probability that 2 students not having a birthday on the same day is 0.992. Then what we will have to find out? The probability that the 2 students have the same birthday. Okay, and how we will do that? Now we just remember, we just go just 3-4 slides back. We just study about the P naught and P. Okay, when we have to find out the P naught. Okay, P naught and PE of the event are what? Just opposite. I already told you. And what P naught is exactly equals to 1 minus P of E. Okay, now go through their definitions. Okay, when we talk about P of E, what is P of E? P of E is the probability of happening of an event. And when we talk about P dash, it means probability of not happening of an event. Okay, is that clear? So probability of happening of an event and probability of not happening of an event are acceptable in this formula. Okay, we have studied in the last thing, and these are complementary to each other. So we have P of E as 0.992 and we have to find P naught. Now what is P naught here? P naught here is the probability that 2 students have the same birthday, and P of E is 2 students not having the same birthday. Okay, so it will be 1 minus 0.992 and we will get 0.008 and this will be the answer. Okay, is that clear? I guess is that clear to you and you are okay with the answer also. So the probability of happening an event is equals to 1 minus not happening of in that event. Okay, or we can write the vice versa. Probability of not happening of an event is equals to 1 minus probability of happening of an event. If the birthday is not falling on the same day, so we will find out the birthday that will fall in the same day. Okay, so what we have learned so far? We just see the theoretical and classical probability. What is theoretical and classical for probability? Where we make assumptions, and we also learned a formula here. What is the formula? That P of E is exactly equals to the favorable number of outcomes upon may possible number of outcomes. Okay, we have done this formula. After that, we will see the definition and explanation of complementary events. What are the complementary events? It complements each other. Okay, that are the opposites of each other. Okay, what are the impossible events that cannot happen? For example, getting 2 heads. Okay, when we toss a coin one time, is that possible? You will get 2 heads when you toss the coin one time. No. So this is what? This is an impossible event. Then we go for the sure and certain events. Sure and certain events, ये तो होगा ही होगा. Like for example, if I say, if I toss a coin and the probability of getting a head and a tail, it's simple. Okay, it will certain. Either it will be tail or either it will be head. Next we just do the questions related to the probability. And I hope you will be able to find out every issue to your problem. Okay. And the lesson will make you good. Okay. And you will just learn about it. Okay. So after going to the class, to the next class, just do one thing, just comment in the comment box that if you want something more, and share and subscribe this channel for more updates. Okay. Thank you so much. Have a good day ahead, and thank you. Learn well, do well, and stay safe. Thank you so much.